Alright guys, how you doing? Now, since you've all made fun of me of how I talk and the jokes I make and the screaming and not talking loud enough, I tried a couple things different, so we'll see what happens. So hopefully I'm talking loud enough for you. If not, I'll scream next time and get you all really mad at me. Anyway, this is what we've been working towards. First of all, this is calling Flip the Classroom, like we talked about in class, where all of a sudden you're going to do notes in class and you're going to come back with questions. All right, so please don't feel bad if you go home and this doesn't make complete sense. You're going to come back in class and do the homework in class. Me and whoever else is in the room is going to be able to help you with some of these things. So don't sweat it if this isn't completely perfect. This is supposed to be a little relaxed now. You're at home. You're just taking notes. Just do the best you can, and we'll talk about everything in class. All right? So again, today we're asking about how to solve an equation. Remember, an equation is a little bit different than an expression. An equation is always going to have an equal sign. It's the root word of equation is equal, and that's what we're looking for today. So our goal in this is to isolate the variable. Right? To isolate the variable, which means get the variable by itself. All right, so that's what we're going to look at. We're going to look at how to get the variable by itself and kind of move from there and kind of see what happens. All right, so now what we're going to look at is just basically some steps of how to look at it and see what goes on. All right, so first of all, just like we've been doing, on each side of the equation, what we're going to do is we're going to collect like terms. It's exactly what we've been doing in class with expressions. We're going to do the same thing here. All right. Then what we're going to use is we're going to use the word inverse. All right, we're going to use inverse operations. All right, so don't let the word bother you. All an inverse is going to be is something that gives us the identity. Remember, identity is what you get back. You get the exact same number back. So, for example, in addition, I want it to be 0. In subtraction, I want it to be 0. In multiplication, division, I want it to be 1. We'll talk more about that later, what that means. So when you see the word inverse, what is the inverse of addition? The inverse of addition is subtraction. All right? The inverse of subtraction is going to be addition. The inverse of multiplication, give you one wild guess what that's going to be. That's going to be division. And the inverse of division is going to be multiplication. And we can just go ahead and abbreviate that for now. All right. So what you'll hear me say a lot is inverse can mean, for us, for now, it sounds like we're talking about the opposite. The opposite of addition is subtraction. The opposite of subtraction is addition. But that's not what we want to think of. All right. Inverse is going to be something different. So the inverse of addition is subtraction. The inverse of subtraction is addition. Doesn't necessarily mean opposite. All right. So then what we're going to do is we're going to use the inverse operation. All right, we're going to get rid of addition and subtraction first. All right, then we're going to get rid of multiplication and division second. All right, so right now, just think to yourself like, I don't know what any of this stuff means. Don't worry about it. All this stuff right here is a way for you to go back and just say, if you get stuck, what do I need to do next? How am I supposed to start? What do I do next? All right. So don't get bothered by all these words. So basically, this is just a kind of a way to get us started. All right. So let's look at an equation now. All right. So when I see solve the equation below, first of all, what do those directions mean? Again, we want to isolate the variable. All right. We want to isolate the variable. All right, we want to know what x is. What minus 5 is equal to negative 1? All right, and so that's what we're going to look at today. So we have this little graphic organizer to help us figure this out. So what I want us to do is, if you see this thing in the middle right here, this thing in the middle is always going to be our equal sign. The idea with an equation is to keep it balanced. X minus 5 is on this side, negative 1 is on this side. They're equal to each other. So when you have a scale or something like that, whatever you do to this side, you have to do to this side. And that's what we're going to look with algebra here. So we're going to use this little graphic organizer, x minus 5 equals, always in the middle, negative 1 over here. All right? So what I want to do is I want to get x by itself. So my goal down here at the end is to know what x equals. All right? And that's what I want to figure out. So now what I'm going to do is I'm going to say, okay, what's on the same side as x? Well, there's a minus 5. And you're going to hear me say it over and over. All right, so I want to get rid of the minus 5. I want the minus 5 gone. So what's the inverse of minus 5? And that's where we're going to get that idea of add 5. But the rules of algebra, whatever you do on one side, you have to do to the other. And notice there's one on this side of the equal sign, and there's one on this side of the equal sign. All right, so now the point of the inverse is to make these things go away. What's a negative 5 and a positive 5? It's 0. So these cross out. And I'm left with just x equals. Now I'm going back to what we did the first chapter. What's a negative 1 plus a 5? So I come down here, get away from this sometimes. Don't do it all in your head. Tell yourself negative 1 down, positive 5, 1, 2, 3, 4, 5. These cancel out, and I'm left with 4. So that's my answer. X is equal to 4. And again, like I said, that was our goal. X equals something at the end. So that was just extra space we don't need now. All right, that's my answer. I'm done. Now I can check it. 4 minus 5, does that equal negative 1? And it does. All right, so now what I want you to do, take a couple seconds, try B. All right, so go ahead here when I get finished talking, pause the video, try B. Now the difference between now and in class is I'm not going to go over B right now. We're going to wait to come back in class and see if we can go over B together in class. So when we get done with the video, I'm not going to come back here and do this. So when I come back after the video, I'll try to say pause it and you try it. Go ahead and unpause and we'll move down here to C. All right. So here in a sec, when I say go, what I want you to do is try B. When you get finished, continue the video and we'll move on with the examples. So go ahead and pause now. All right, so now we're going to go down to C. And again, you're going to see fractions. Don't worry about the fractions. They're just fractions. Who cares? All right? So x plus 3/5 equals negative 2 over 7. Right? Just like we've been doing before. Take that minus that's in front, bring it up top to the 2. All right? Equals in the middle. So I want to get x by itself. So what's on the same side as the x? A plus 3/5. So what's the inverse of plus 3/5? It's minus 3/5. Whatever I do here, I have to do over here. All right? So again, I'm going to ask myself, okay, what is a plus 3/5 and a minus 3/5? It's 0. That's easy. That goes away. So on this side, I'm left with just x equals always in the middle. Now here, all of a sudden, I'm like, I can't do that in my head. So don't come down here. All right, negative 2/7. All right, and what you can say is this is always addition. So you can say plus negative 3/5. Now here you can do common denominator or crisscross across. So I can do crisscross across. So that's negative 2 times 5 is negative 10, plus 7 times negative 3 is negative 21, and then that's 35. And that equals negative 31 over 35, and that's my answer. Negative 31 over 35. All right, so recognize here, you look at the fraction, you're like, oh, I don't understand this new stuff. The only thing that's weird here is adding the fractions here, but that's what we've been doing. And you may say to yourself, Mr. Hyde, I thought you said that was subtraction. Remember, we said it a lot of times in class, there's not a big difference between addition and subtraction. All right, so come over here. And let's go ahead and just change this now. All right, and I'll get you started a little bit, but I want you to try the rest on your own. So we write it, x plus 3 2/5 equals 4 3/7. Now, before we start, like I said, I don't like working with mixed numbers. So let's get rid of it. Let's leave x plus 5 times 3 is 15, plus 2 is 17, so 17 over 5 equals 7 times 4 is 28, plus 3 is 31 over 7. Now we have an example that looks just like the one over here. It's just improper fractions. So go ahead and pause. Try this one. When you get done, start the video again, but we'll go to the back side. So we'll finish this in class when you come back the next day. So go ahead and pause now. All right, so now take your sheet, flip it over. All right, we're going to try some of these examples down here, back here. All right, very similar. All right, very, very similar. Not necessarily going to be anything really difficult. All right, so the idea here again, let's write it. Negative 5x equals negative 10. This time I said isolate the variable below. Different directions, same idea. All right, so you're going to see the directions, a lot of things. Solve the equation below. Isolate the variable. Find the value of x, you could see sometimes. So find the value of the variable. So you can see a lot of directions like that. You don't have to write that. I know some of you are writing it right now. Don't worry about that. I'm just telling you different directions mean the same thing. So I want to get this x by itself. And you go, oh, so what does this mean? So first of all, let's ask ourselves, what is the x in this number doing? So you'll hear me say a lot, what does it mean to say negative 5x? And again, remember that means times. All right? So ask yourself, what do I do? So what's the inverse of times? Well, we said that before, division. All right? So I can do it either two ways. I can either do a division sign, or I can do a slash, right? Like a fraction. But I can do division either way. All right? So it doesn't really matter either way you do it, division or like the fraction number. So I can put division over here just to be the same. So what happens is the signs are changing. Times, divide, but the number stays the same. All right, so there's a times negative 5 over here, so I'm going to divide by negative 5, divide by negative 5. And the reason is what's a negative and a negative? A positive. We want the signs to go away. What's a 5 divided by 5? It's a 1. All right, so this is technically 1x. All right, and we'll come back to this in a second. Over here, what's a negative divided by a negative? What's a negative divided by a negative? It's a positive. And what's 10 divided by 5? That's going to be 2. So now I say, okay, what's 1 times x? Oh, that's just x. So that's 2, because anything times 1 is itself. Right? And that's my answer. X equals 2. All right? Don't go fancy here. And I'll come here in a second. So here it works out easy. It's 2. Over here it's not going to be as pretty. But just leave it as a fraction or leave it as a mixed number. But don't go to a decimal. Just stay with easy. Sometimes fractions are okay. And then we'll talk about that in here in a second. But check yourself. Negative 5 and x is 2. What's negative 5 times 2? It's negative 10. All right, so it's one of those things we can look at and kind of figure out. So once again, try B, see how you do. Press some pause. We'll go from there. So try B real quick. All right, so now we come to C. All right, now we come to C. We can write this. 3/5 x equals negative 2/7. Notice I put the negative on top. And you look at this going, oh, this is ugly. All right? But again, it's just fractions. It means times. So what's the opposite of times? All right? Opposite of times is divide. So I can put divide 3/5 here and divide 3/5 here. Now this part looks whatever, but it's, again, what's 3/5 divided by 3/5? What's anything divided by itself? It's gone. It's 1. Because we said up here, 1 times x is x, so I can just say x now. It's gone, so it's just x. Equals, again, there's no way I'm doing that in my head. So I come down here, negative 2/7 divided by 3/5. All right, and this is that whole KFC thing. You know how I feel about KFC. All right, I love me some chicken, but I don't always love KFC. So remember, it's KFC OD. Kentucky Fried Chicken, only drumsticks. But the whole point of here is that you have to remember this is only division. You do KFC. So negative 2/7 times, so keep it, flip it, change it. So this becomes negative 10 over 21. Then I ask myself, is there anything that goes into this? Is there anything can this reduce at all? Well, the only thing that I know that goes into 21 is 7 and 3, and 7 and 3 don't go into 10. So that's my answer, negative 10 over 21. All right, so same idea here. All right, we can definitely check this later on, but we'll talk about that in class later. All right, so same idea over here. What I want to do is I want to change this to an improper. All right, now just remember at this point, some of you are like, Mr. Hyde, you're going so fast, slow down. There's this wonderful thing that they created a couple years ago called a pause button. Pause, rewind. Tell me, listen to it again. As much as I know you don't want to listen to this video one more time, but pause it, rewind it, say it again. But if you ever try to do that in class in real life and say pause, rewind, I'll tell you I'm not YouTube, so get over it. Anyway, so we'll get here, change it to an improper fraction. 5 times 3 plus 2. So this is 17 over 5x equals 7 times 4 is 28 plus 3 is 21 over 7. Oh, look at me, totally messing that up. Oh, man. You guys got to find a better math teacher. 7 times 4 is 28 plus 3 is 31. 31. And right there is a wonderful example of why we don't use pen. All right? So 31 over 7. And again, follow the same thing over here. Try that, pause it, go on from there. All right? So try that, come back in a minute. All right, so if you tried that, we're almost done, I promise. I know this feels like forever, but this is one of those things that looks, this one right here, if I could convince you that this is 100 times easier than it looks, I'd be so happy as a teacher, because this is one of those things that just bothers students because it looks so hard, but I guarantee you this is really easy. All right, so first of all, let's look at this and let's say what this means. This is z over 5. Now remember what a fraction means. A fraction means division. All right? So a fraction means division. So let's write it that way. Let's call it z. And I know what you're thinking, Mr. Hyde, all of a sudden change the example. Look at the whoop-de-doo, now it's a z. But again, the variable doesn't matter. All right? It doesn't matter if it's a z or an a or a b or a smiley face. All that matters is it's a variable that we don't know about. All right? So z over 5. So let's just call it z divided by 5. Equal stays in the middle, -1. Now here's the fun part. What's the fun part? Yeah, right. Honestly, but here's the part that makes it easy. What's the inverse of division? Well, the inverse of division is multiply. So I'm going to multiply by 5. Numbers stay the same. I'm going to multiply by 5 over here. So these cancel out. Because if I divide a number by 5 and times it by 5, that just, goes away. Try it with your age. Take your age, times it by 5, and then divide it by 5. You'll get your age again. All right? Share with your friends. Bring it to parties. You'll be the hit. Everybody will love you. Everybody loves math at parties. All right? So these cancel out. I'm left with just z equals in the middle. Negative times positive. Negative times positive. All right? Is a negative. All right? So again, that's going to be a negative. 1 times 5 is 5. That's my answer. Which should make sense, because a -5 over a 5 equals -1. All right? Now all you do, try F, rewrite it, try F, and you're done. All right? I know you've been probably sitting here for 20, 25 minutes taking notes, but again, it's one of those things where I want you to try this, look at it a couple times. We'll do the homework in class and go over it there. So I know this is going to be, right now you're doing it a lot, but again, I think this is going to be a little effective because you can keep watching this video over and over. Again, if right now your head is like, oh my God, Mr. Hyde, I have no idea what I'm doing. I'm so confused. I don't get this. This is so hard. Don't worry about it, because you just did the notes at home, and now you're going to come back to school, and we'll do the homework together in class. All right, so it'll be a little bit different. So you won't have to just be by yourself doing the homework. We'll do it together and talk. You'll do it as a group, and I'll kind of go around and see what I can help you guys with. All right? So right there, we're finished, and I will talk to you guys in class tomorrow. All right, take care.